All right, let's go ahead and get started here, folks. All right, so I want to do something different for this session. How many of you have been involved in an open source project before? Actually actively engaged in it? Show of hands? All right, good. So not very many of you. Well, you're going to get an introduction to it right now because everybody has to participate in this next session. All right? I want this not to be really a user panel. I want this to be a user forum. All right? I want to take this opportunity for us to share what we're trying to do with OpenDaylight, what things have worked with OpenDaylight, more importantly, what things haven't worked. What are you waiting for? What would you like to see happen? That can also apply to anything associated with NFV. What's working in NFV? What are you waiting for? And in particular, how they might come together. All right? I've got two gentlemen up here with me. I will let them introduce themselves. They are both here because I know they are actively engaged in OpenDaylight, as well as NFV activities. I know that some of you in the audience are also engaged in OpenDaylight and activities, and I'm going to call on you. So I will warn you now, all right, because I want us to share what we're doing, okay? Mathieu, would you mind?
So you guys can, okay, perfect. So I'm Mathieu Lemay, I'm CEO of InnoCybe Technologies. InnoCybe is the pure play OpenDaylight company, so we have been focusing on helping people leverage OpenDaylight either within their products or solutions. So we've been facilitators. If you think of it as a set of technologies, if OpenDaylight's a set of technologies, you actually can leverage it into building a variety of things from SDN controllers to WAN controllers to smart city controllers or any other type of systems. And therefore, that has been our involvement within the project and the community at moving everything forward.
Randy?
I'm Randy Levenshaler. I'm at Cable Labs, where I'm an architect working on kind of defining kind of our NFV infrastructure for our members who are the cable operators around the world, as well as looking at orchestration. And a big part of that is OpenDaylight and using OpenDaylight as the controller for controlling things like CMTSs and a lot of the cable systems. And before that, I was at HP working on Linux open source, as well as some of their early OpenStack initiatives.
Very good. Martin, you mind talking about what you've been doing? Neela mentioned this a bit in the morning. Randy, or Mathieu rather, can you share mic?
So my name is Martin Skorupski. I'm from High Street Technologies. We help service providers with all topics of SDN. And doing so, we also try to achieve a standard for microwave, for microwave configuration API towards the devices, a common YANG files for netconf YANG, which should be implemented in the devices. And doing so, we used OpenDaylight in one of our proof of concepts from the ONF. And basically, that's what we are doing.
Very good. Thanks, Martin. Anybody else like to share what they're doing, what their role is, and what they're doing with OpenDaylight and NFV? What you're trying to gain out of this, this particular mini-summit? Yes, sir.
Only short comment. Roland Schott, Deutsche Telekom AG. Yeah, I'm here located from Deutsche Telekom, and our intention is to move our network infrastructure into data center structures and take OpenStack or open source software for future work, and therefore we are interested in what's going on in the community.
Very good. Yes.
I feel I probably have to introduce myself, even though I'm here in more of a learning capacity today. I'm Susan James. I'm heading up the product line for NFV infrastructure in Ericsson. So that obviously includes SDN. So but I have a responsibility for our more for our OpenStack and OpenNFV engagement as well as our product portfolio.
Anybody else willing to share? Yes, in the back. Thanks again. We end up doing a lot of this with our advisory group. It's obviously a little bit more spaced out, but as we have the opportunity to be here in Europe, to meet more European operators and those looking to do both SDN and NFV, this is why I want to take the opportunity. I get to listen to what's going on here, and I get to take this back to the community, right? And you will have a true impact, all right? So if you got things you want to say, now is really the time to say it. Please.
Hi, my name is Gaara. I work for Ericsson. And I have been committed to hydrogen and the helium release. But I'm also using the beryllium release and looking forward to this session for more of SFC stuff and more of the active engagement to OpenDaylight.
Very good. Go ahead, Matthew, in the back.
Sorry.
Hi, my name is Sven Bender. I'm with the Ericsson Network Management Lab, so it's like all Ericsson in this corner. We're building European 5+ infrastructure for new network architectures for 5G systems, and I was interested to understand a bit more on ODL, and if I can use ODL to actually manage networks with a way different network stack than TCP/IP.
Anyone else?
Others? Okay. Oh, good.
Hi, my name is Michael Schwarzkopf. I'm from company Sys4 AG, based in Munich. I haven't done anything with OpenDaylight software development network at all. So that's why I'm here to learn about OpenDaylight and software defined networking. I've been doing a lot of network management with SNMP for the last 15 years. Would be interesting how to interact with SNMP and OpenDaylight.
Okay.
Anyone else? Wants to go?
Anyone else? For those that just entered the room, we're doing this session a little bit different. I'm actually wanting to turn it into a user forum. All right. I want to hear from those in the audience things that are working with OpenDaylight, challenges you're having. And basically consider this as a conduit going back into the development community.
So
all right.
We want the bad stuff now.
say that again?
I said we want the bad stuff now.
Yeah, exactly. I mean, this is one of the things that open source is doing. We're not going to put a pretty bow on our code and say it's done, come buy it, right? That's not what this project is about. It's not what any open source project is about. It's always about understanding what's the most important thing to be doing next, to continue to evolve the code, right? So we're quite happy in, whatever it is our problems and our warts are, so that we know what it is we want to attack next.
Go on. And anyone wants to jump in on their experience, how they found it, or that have played with it and is still looking for the documentation part of it?
With that, well, yes. If somebody doesn't mention documentation, I know you're all asleep from lunch, okay? So I will understand that. But Mathieu,
Yes.
Talk to me about some of the challenges that you've seen in your customers. What are you solving? What are their biggest issues?
Well, I think one of the biggest challenge that, just from an OpenDaylight overall perspective, has been to really understand what OpenDaylight can provide and deliver, especially because there's so many pieces of technology there that can be leveraged to solve a variety of business cases. So what we've actually been looking into is what business problem are you trying to solve and automate, and really looking at OpenDaylight as this toolbox. And what we would love to kind of hear more about from this crew is really what are the challenges and what are the things or the pain points that you guys are facing, so that OpenDaylight can evolve in the proper sense. For just to get back to some of the use case, It varied quite a bit from traffic engineering to either cable devices automation down to like cloud NFV related scenarios. So the scope has been very wide into what ODL can deliver and provide, which also makes it harder for people to understand and get started with it. So that's kind of how we've seen the community so far, and would love to hear more about what you guys have in mind.
Very good. Can you elaborate rather a little bit more on the IoT and the smart city activities?
Yeah. So yeah, we've also been involved in pushing the limits of OpenDaylight. The way we've looked at OpenDaylight is, yes, there's the SDN component, but think of it as Network Plus. So it is about modeling the net and operating and working with the network, but also about everything else that is connected to this network infrastructure. What OpenDaylight gives you is the ability to turn your infrastructure into living documents. And it is the foundation of smart infrastructure, whether it's an IoT or smart city, smart building. You actually can turn infrastructure into this living document that you can then operate and manage. When you first go into OpenDaylight 101, the first thing you learn is about modeling a toaster, which has definitely nothing to do with networking. Therefore, as you actually leverage this solution, it can be leveraged from HVAC, electric utility, down to the typical SDN and NFV use cases. So we see this platform as a powerful framework for leveraging smart infrastructures in the future. That's kind of how we, yes, any questions? Yes?
Colleagues of mine are very good in managing email and building email structures. And this morning I learned a lot of that you can manage your routes with OpenDaylight. Is it somehow possible, just came into my mind, is it possible to manage email routing with OpenDaylight? So if this server can't send the email out because it's on blacklist, can reroute the email to the other server and send it through that gateway? Yeah. Or policy-based email routing going to that address goes through that gateway or something like that?
So the answer, I would say most definitely yes. Just to get back to the actual picture that Giles drew, which is that feedback loop. The main thing to understand about OpenDaylight is it's a reactive platform, right? So it was designed to be reactive and allow you to react on events that are happening within the underlying environment. And that feedback loop is the core of everything that is OpenDaylight based. Therefore, if you wanted to react on policy, on email, or anything else, the thing that you would have to do is, of course, tie this into your networking strategy and also model the email part of it as an extension or an application or whatever you want to do that brings the additional logic to it. And you tie in that feedback loop, which allows you to really monitor, control, and operate that into a proper reactive cycle around your infrastructure.
What would be concrete? What would we have to do if we want to do that? Plugins to OpenDaylight, or what would you have to do?
Basically, what I would do is I would probably tie that into some of the existing components, like, for example, BGP and maybe group-based policy, depending on the approach that you're taking there. And I would add an additional southbound that is specific to your mail server or your mail environment, or you can actually do it more from a networking perspective. So you can decide whether you do it from a pure networking angle, which actually looks at it from a networking protocol angle, payload and management, and look more at what's coming in. Which would be a different strategy than tying it in your email server or your application or email application. But both ways, you can do it both ways. It's more of a matter of whether you're trying to be agnostic and whether you're trying to abstract in that situation. But first things first is you model whatever you're trying to achieve, and then you leverage the existing components that will make your use case better. I know I'm not as practically answering your question, but if you want, we can continue that offline. It depends on your infrastructure and how you're actually...
Yeah, and if you're using SNMP, there's already a southbound SNMP that
Yes.
could be extended for that, so you wouldn't have to rewrite that protocol stack, which is one of the really nice things about OpenDaylight is with the model-driven approach is you really can bring in new components quickly, which is something we've done in the cable industry with PCMM to do call quality over cable modems, which is a very different protocol, DOCSIS. So we've had to add that, but again, using SNMP, that's something you can use on the southbound and then doing your modeling and your northbound application.
Absolutely. You could even...
Yeah.
It's a problem because Postfix doesn't have an SMP agent. Not yet, we are working on it, but not yet.
Right, so you might have to then tie in some other orchestration type of application that's going to be monitoring your mail server. Right, and that could either go embedded into OpenDaylight. Some folks have done that and put those kind of services in and even created a southbound to talk specifically to an application. I mean, that's one of the interesting things about this platform is it's rather flexible in that sense, and you can do those types of things to it. Folks are actually using OpenDaylight as a master controller to manage other versions of either OpenDaylight or other controllers as the southbound, as yet another example, to be able to tier those. So yeah, when it comes to that type of application, it's quite flexible.
And actually, just a way, I know I've mentioned it very rapidly, but a way to think about OpenDaylight is it's just that living XML document, right? And your applications are the JavaScript equivalent to what you would find in an HTML browser. So your infrastructure with the southbound protocols becomes that living XML document, and then your application simply subscribe to node changes a little bit like you would subscribe in a web browser, and can do and perform a variety of elements. So think of it as a web browser for network-ish platform.
And Randy, can you talk a little bit about what Cable Labs did with PCMM as well as what you're looking to do and places you're looking to interact for NFV and for the larger picture?
Yeah, so PCMM was kind of our first foray into OpenDaylight. We wanted to see, what does it take to add new functionality and to bring it into controlling cable-specific devices. And we only had a couple engineers on this project, and we basically worked with some vendors, and were able to set up basically a new band for whenever a call is initiated and control the quality of service down from the cable modem back to the IMS system. And it works fairly well and does, it's being still continued to be developed, and more people are looking at rolling it out. So that's really it was done because it was something that was, dynamically controlled on the cable modem, something people were looking at, and also just as a proof of concept. And so now that we've done that, we really have, sold that, and there's some general acceptance, or, not sold it for money, we're not for profit, but just sold the idea of that. And now our operators are really seeing OpenDaylight as, ability to control any device. And looking at, I think the challenges now are really looking at, how do we scale this? How do we add the availability? There's still, being a service provider, right? Really some hesitation sometimes to really go with a new technology and scale and look at the reliability. So I'd be interested to hear, people, that are running it, what scale you've gotten to, if you've run into any specific availability or scalability issues. That's really what we're looking at. How can we do the access network and control it, and have kind of one northbound API that will control both DOCSIS, which is fiber copper network, as well as like a PON, EPON, or GPON network that's pure fiber going to customer sites. And that way we can really abstract a lot of our services at the northbound layer. And then when it comes to actually talking to the devices on the southbound layer, OpenDaylight will then know to translate the Yang models or whatever to netconf or to SNMP to control the various devices. So that's really where we're going next is, how do we scale it, and also how do we, work across domains, more than just a data center, right? We want to connect all of our domains within one service provider, and some of our operators, Comcast, Liberty Global, are very large, and also how they connect together because, for business services, we often need to provide the service, from a variety of providers. So things like Metro Ethernet, which is either was an earlier or is the later talk, Is again another use case we're looking at in layer 3 VPN. And really, how can we use OpenDaylight for those, and will it scale, and will it really provide that, 5 nines, or some people are even talking about 6 nines as you start moving into the NFV space, and that's really kind of where we're focusing it.
Very good. Yes.
Thanks. So I will show some ignorance here for you all, but I'm here to learn. I like to play the devil's advocate, and what is being done in order to not recreate the EMS mess, but perhaps creating new types of silos that used to be vendor silos, and now it becomes IoT silos and cable lab silos and things like that, or yeah.
Yeah, that's a great question. So, the EMS mess, or, where we actually are tied, specific end units at customer sites are tied to the EMS system. And as we do acquisitions in the cable industry, we suddenly have, all these, 5 or 6 EMS systems, and each EMS system has 5 or 6 physical devices located at the customer site, and start thinking about, managing firmware, upgrade cycles on all of those. It's a nightmare. So I think that's sort of where you're going with that. And really with this, one of the things is, since we're going software-defined, we're seeing collaboration in the service provider space between cable operators and telephone operators, as well as enterprise. So we're actually seeing a much larger collaboration on the user side, as well as on the service provider, or the vendor side. So that's one of the things we're going to. There is still the risk of some silos, especially at the orchestration layer. Everyone's using, Tosca, but it's a different version of Tosca. So there's still some risk of silos, but we're really trying to do, more and more open standards, more and more Yang and NetConf and things like that on the northbound and southbound. So there is still a risk, but I think, with more and more vendors offering OpenDaylight as an option, or offering ONOS as an option, I think we are less likely to get down that path, but it's still going to take vigilance and working with actual interoperability and standards bodies to keep that going.
Yeah.
Well,
Go ahead, Mektu.
No. Well, basically, I agree. I think the fact that going towards open frameworks is helping. Sometimes it can also create fragmentation because of the ability to modify or change. But I really believe that as this platform is now being used, we see a lot of use cases where, in fact, ODL is used to reconcile a bit of that EMS mess. So that is a common use case where people will no longer, they will fear the next M&A, or they will fear the next product that comes in, a proprietary product, and they will bet on OpenDaylight as their internal strategy. So it's more of a do-it in-house type of approach, or absorbing some of it in-house in order to minimize the risk. So then they can bet on the technology over a longer period of time, even though so it can evolve and integrate and operate with the various EMS or boxes that they will bring in there, like vendor boxes that they will bring in their environment. So
yeah, and no, very good, Mathieu. And I'll also just take this as an opportunity to point out, I know many in the room are very new to open source, but that's one of the key benefits, right? Neela in his talk this morning talked about how a very large over-the-top provider was talking about mucking around with BGP routes, and the carriers were like, what's going on? And yeah, and that's a slippery slope, right? And everybody knows it. They even know it. They have to do it. But the conversation starts there, right? One of the things I find most powerful about open source is that you get the technologists who are down in the weeds and understand all of those topics talking to one another, be it different users of different types, again, carriers over the top, different spaces of carrier and SP versus the vendors. Again, you're talking to vendors that you may or may not have relationships with. It doesn't really matter in the open source realm. My point being, the more you're able to get involved, the more you can actually affect radically those types of outcomes, because the things that you step back as a user and a customer and go, that makes no sense. Why did anybody ever do something that way? You can actually affect it before it happens because you're part of the development process.
Yes. And I totally agree. what I mean, though, is I am not against open source, so that's not it. But it creates, as I said, I'm playing the devil's advocate a little bit here. So,
No, please, devil away.
it creates the opportunity to solve a lot of problems, but each solution to all these problems might actually cause a problem somewhere else. That's what I mean, where you remove the EMS mess, which was like vendor-based and so on, and then all of a sudden you have your application that is doing BGP stuff, solving that problem, but that screws up things somewhere else. And how do you make, you have a new world map that you have to deal with that used to be EMS-centric or whatever, and now it becomes, I don't know, different kind of silos. That's my what I'm afraid of a little bit. How do you solve that?
Right, and again, I don't have a silver bullet answer. What I'm saying is that silos are created because those in that vertical space that they're working on are ignoring everybody else. Right. The nice thing about things, it's people, absolutely, and it's people trying to get something done. The nice thing about open source, and particularly OPNFV in that regard, is you've got an entire sandbox with all kinds of pieces that used to be very siloed, and an opportunity to not let it be siloed, because those conversations can happen, and they happen without business motive. Without business motive is a bit strong. The business motive is muted because developers care less about the business motive and more about a sound technological solution. Again, this is, and it's an opportunity, right? We've never done this. This industry has never done this. This is your opportunity. Again, not a silver bullet, but there's a lot of upside to the way this model works. And it's all about getting involved.
But I think you almost said the same thing that I was planning to say. This is what OPNFV is all about. I mean, you take the software, you test it together with the rest of the software, and you actually see, does it work? And I think, the experience that we had with the early OPNFV and OpenStack testing proved that, yes, what we thought would work actually didn't. And so now we've made improvements in both lots of software so that going forward, they will work together in the way that we would like them to do that. And you still have the standards bodies defining different things that then, provide a framework to work within. The open source communities build the software to do that. And then at the end of the day, we still manage to get essentially the best of what we had in the telecommunications world, but also the best of what we have in the IT world with open source. So I think, that really is an evolution of both industries coming together to establish something much better going forward than what we've had on either side, I would say.
Yeah, absolutely. And I'd even follow that up with just the fact that, we talk in the beginning about OPNFV being this place where you test stuff to have it work together. And that's a great end goal, and it's a really good place where OPNFV started from. But if you look at what we have now in this ecosystem, right, we have OpenO, we have OSM, we have a variety of orchestrators that are now popping up. We have several different controllers that are popping up. We have packet processing engines like FDIO. Obviously OVS is in this space as well. Point being is that you've got a variety of components that not only do you just want to be testing with them, but now with OPNFV, what you want is each one of those components, as they're building their next feature, the distribution they test against to see how their features are going to work is the last stable release of OPNFV. And when you start to build upon that and use that as the base from which you develop, I watched this happen in Linux with Debian in particular. Okay, for those that don't know the Linux ecosystem, there's an operating system called Debian. Ubuntu actually comes from it, but long before Ubuntu existed, all of the developers in IBM and HP, where I worked, and every place else, Red Hat, wherever, they all worked upstream with Debian distributions. And they did it for exactly that point, right? HP is coming out with new hardware. We were using the Debian distribution to be testing the extensions of the kernel that we were doing. Because it was stable, everything was upstream, you knew it was all available to everybody, and that was the core from which we started. OPNFV has this opportunity. It is not yet realized, but it is the opportunity for what OPNFV can do for all of these places. And the important thing there is when we start getting all of the VNF application vendors, they can be using this as well. And so all of that coming from a common upstream base is just a much easier way to get to market with something that works across all of those components. And again, with an opportunity to not have those silos. Any other comments on this topic before we move? And thank you. This is exactly what I wanted. All right, keep up the conversation. All right, then I'm going to move and kind of dig in a little bit more with orchestration. So orchestration's been getting a lot of attention. We've got TACR, we've got OpenO, OSM, eComp. I would like you to share your views on the importance of coordinated orchestration with the VNFs across both the Vim and the SDN interfaces. Right, this is a place where, again, from an OpenDaylight standpoint, I want to understand what are the users' most important concerns as they start to implement those type of orchestration engines. What should the controller be able to do? Where do you see the interaction between an orchestrator, the Vim, and the SDN controller, as an example? You know, I know what OpenO's view is. I'd like to understand your perspectives as well. And Mathieu, if you've got any thoughts on this, or Randy, I figure both of you might have thought about this a tad. So please share as well, but the audience as well.
Well, I have potentially a different point of view than most, but because I've been a backer of the Armoury project. So in other words, in many cases, I like to start VNFs from the controlled infrastructure on the underlay type of infrastructure without necessarily seeing it from a service perspective. So basically being pure like end-to-end infrastructure play where you are more of a data utility or more really the infrastructure provider that is completely decoupled from the services that are then offered on top. So I'm really unbundling that from that perspective. But that's, again, a personal preference. There's many other ways that this has been approached and looked at, but Armoury is basically something that will evolve over time in OpenDaylight. It's lacking a bit of momentum and resources, but I believe that as you can actually integrate NF cataloging and also the ability to turn on and off workloads across a variety of workload providers, OpenStack, Mesosphere, or any other like containers, Docker. So you basically have the ability to have a lightweight solution to orchestrating and managing your VNFs in a more utility or low-level infrastructure point of view. But with OpenO and other things at a higher level, there's also these solutions that can tie in, and I'll let you go over these ones.
Yeah, so OpenO, OSM, Cloudify, what are some others? OpenBaton is much more, higher level, and this is kind of the approach we've been looking at as, having more of a global orchestrator that has a view of the entire end-to-end service, or maybe a tiered model, and this is something we're vetting out a little bit, is, because you still want the availability and to be able to manage within the fault domains, but you also want failover, so that's where we're looking at this from failover and really being able to optimize resources as well, because, even for a service provider, it may be less expensive to go to some hyperscale cloud provider for doing log storage than it is to use your precious data center space that's right in band with the network. So we're really looking at how can you coordinate all that, how can you optimize that, and how can you do it repeatability? How do you bring in a VNF onboarding? And I think that is actually one of the big pieces of the northbound of the orchestrators, onboarding the VNFs, as well as scaling them and producing them for individual services. And another thing we're looking at is some services like IMS might make sense to have that as a shared service. So where everyone uses the same IMS server, but other things like a firewall, you'll want a per customer instance, and those things will need to be managed a little bit differently. And I think we'll have SDN controllers at various levels. So you'll have your underlay SDN controller, and that may just have a northbound API to your higher level SDN controller because you might want to have some, security and isolation, and those might both be OpenDaylight or they could be different ones. And so that's where we're kind of, trying to make this a little more modular and separate it and also meet the service assurance needs. That's really what we're looking at right now. I think that, it's great that we have all these competing open source projects, though, to really go in and break up, what were the traditional OSS systems that were all these, very large, very large systems. But yeah, definitely like to hear, folks, if you guys have any experience with some orchestration tools, either in the data center or for the service provider space.
Anyone? Oh.
So I'll be quite unpopular here. Is that, if you saw what Baton presented the other day, we've done all that because we're not open source. So, anyways, a lot of these things have been attacked. We've integrated. So what we did, we've had a traditional orchestration system for years. So the first thing we did, we brought OpenStack under management so that we could bring the VNFs up and that whole thing. We've managed 12 or 14 different vendor VNFs. So your original question was, where does ODL and SDN come into that? So from looking at it from an NFVO layer, now we have to figure out how to chain these things together. So laying VNFs down is pretty much, I won't say it's old news because the VNFs are not very standardized at the moment, so there's a lot of work to that. But so what we're looking at is initially we saw SDN as being inside of the POP and figuring out how we would use SDN capabilities to chain inside a POP. But we also recognize, because we do have an end-to-end view, that SDN could be a potential for broader, for the WAN level stuff, some of the stuff that was discussed today. So the first cut is we brought ODL basically, and then we're looking at using the OVS to route between the VNFs inside a singular POP, okay? And then the next step would be to extend that outwards to broader applications at the WAN level.
Great. Good to hear different viewpoints, I think. Definitely there'll still be proprietary solutions, and I think one of the things that we're really pushing for, though, in the industry is to have common interfaces, both northbound and southbound interfaces, so that way you can have more innovation in the VNF space. In particular, you don't have to have, the whole sandwich, the whole bad sandwich where you're stuck with the orchestrator at the top and the NFVI at the bottom.
Okay, so that's what. Again, can you hear me without that thing?
We're recording, so indulge me. Thank you.
So I so much agree with what you just said, but what happened with OPNFV, and I was massively against it, was it was originally supposed to be an NFVI Vim layer and was supposed to present us with a functional Vim interface, but we decided to run up the model and do the rest of the stuff too. So I would have liked to see us finish the Vim so that we could move on with business as opposed to chasing all the other things here. So we have to watch that sometimes when you allow, and I think someone was discussing this, when you allow the flexibility and the combined sort of capability of all the people in here, you tend to grow maybe before you finish. So I mean, I've seen this in a couple of things, even in maybe some of the ODL things, as opposed to finishing a piece. Well, at SFC today, it seemed like we didn't quite finish the one piece of it, and now we're trying to see what the broader one is. So I think sometimes you have to finish something before you start the rest. Now, I do recognize that one of the problems and one of the reasons that Tacker moved was that to test some of these things, you needed components from the higher level to be able to do that. But I think it had to be framed in what you just said, that ultimately you need that Vim interface to be complete so that whatever rises above it works consistently. So.
Right, yeah, I know there's some timing things, but it was all the intent, as I understand, with OPNFV to grow the scope. It was just for the first couple releases to really laser focus on the NFVI. I don't know if Tetsuya wants to comment. He's on the OPNFV board. No? Okay. Trying to egg some more comments here.
But again, also not too uncommon open source shortcoming as well is moving on until something is totally complete. Often vendors find opportunity in that because they do the completion and they'll create a solid solution out of it. It's one of the balances of open source, that there indeed are gaps to be filled, be it documentation and training, be it complete solid interfaces. Not making an excuse, It's just, the next shiny rock that the developers want to go do, right, as opposed to finishing the stuff that is maybe not a little bit less exciting. Something we do work on in our project and any good open source project, but it certainly exists. Other comments there with their relationship with orchestration and how they're seeing that work, right? There are so many places where the orchestration layer can occur, and Mathieu sits on definitely a different side of that. So other thoughts on where you think that might fit and how it would interface with an SDN controller such as OpenDaylight? No more on that one? Okay. Then let's talk a little bit more about SFC. There are a variety of ways of doing SFC. So, as you look at that, do you see SFC as actually being ready to deploy? Are you planning on waiting until more has been done? Is NSH the preferred method? Or are other methods holding more promise for you? What are the thoughts in the group around SFC? And again, obviously that relates to what it is OpenDaylight should be looking at for methods of implementing service function chaining.
Anyone wants to jump in on that one?
I know, what we're looking at, just to kind of kick it off, is, NSH is kind of one of these things, a great concept, and it's some investigation, but really, I think everyone now is more looking at a layered approach, where you try to separate the physical underlay network from the overlay network, and on the overlay network using things like, MPLS or GRE tunnels rather than NSH for the initial deployments, and then doing, just kind of VXLANs or whatever, or GRE tunnels between the VMs. Though, layer 2 networking is something we're really missing today in OpenStack. And that's really going to block a lot of the use cases. So being able to, and I don't know if this is something where we can get OpenDaylight to help out with, because a lot of the capabilities are there and things like Open vSwitch, but to actually have the VLAN tags exposed to the VM and allow the VM to do the management on the layer 2 or look at all the layer 2 packets and do some analytics on those. So that's, to me, I think that's where I think some of the service chaining can really help out, and trying to tie that with the layer 2, again, close to the physical for managing that.
And Phil, I mean, you raised a good point, NSH, OpenFlow, Lisp, I mean,
there are a variety.
MPLS down to the VM. Honestly, I haven't seen a consistent way. I've been involved in a variety of SFC use cases, and today I haven't seen a consistent way that this has been approached. It varied from one operator to another based on what their preference was, what their backend infrastructure was, how their data center was structured. So I haven't seen any silver bullet on the choice of technology for service function chaining today, and I would love to hear more about what you guys have in mind, because for me it's like the Wild West on that front.
Exactly. So thoughts, comments from folks in the audience? Nobody cares at all about service function chaining.
Raise your hand if you at least care about it.
Is that it?
Yeah.
No, I'm just saying that we've taken, we've made SFC like a capital FSC, and that means something now here, but the general of tying these things together, I don't think there is one approach. And we're trying to experiment with them. We clearly see that SDN and an ODL, which can be broader than the large SDN, I don't know how we refer to that one, but so there has to be a number of options. So I do see ODL as one that's offering a variety of options in that space. So therefore that's good. But I mean, don't think virtualization cut down the options. I think it just added more to the mix. And the real trick here is to try to figure out what really needs to be done and migrate those attributes and that information up into the models so that we know how to onboard these things and both an NSD and the VNFDs that require that type of information. So.
Right. So from the folks that you're working with then, what do you see? Sorry, Matthew, send it back, because I want to ask this question. Of the folks that you're working with, what do you see as their primary method that they're wanting to use for SFC?
Yeah, I'm not sure. So for first of all, the truth is, right at this point, most of our work is with VNF vendors and trying to establish how their VNFMs are going to work and things like that. So to some degree, they're isolated and they're not really thinking necessarily, you know, what happens in between them. So I think tunnels, you know, the tunneling is sort of seems to be the first option in that. But we're trying because I think some of the flexibility when you get into scaling and stuff, I think that an open flow type of view offers some more options in that area than doing tunneling. So that's why we're sort of, that's the next step we're trying to do is to address a lot of things that happen to do with scaling and after the sort of initiate or the initial instantiation process. And so that's why we're experimenting with ODL. So.
Okay.
Is it possible that both will survive, really? Because with NSH, it's kind of handy because the service information. With NSH, it's handy because the service information is a completely separate header altogether. So you get a little bit more flexibility, but you also have a separate header to interrogate, so it might be a little bit clunkier than the MPLS VPN approach. But that's why I can kind of see applications for both. Like I know in the Red Hat demo this week, they're using NSH. And I actually don't know about the Ericsson one, but you know, I don't think necessarily there's going to be one clear winner, but.
Back behind you.
Yes. I must confess I have arrived a little bit late and maybe not aware of all the discussion, but when thinking about the requirements we put on how to use service chaining, one of the things is that we would like the functions to be completely oblivious of what is happening. And for that for that purpose, normally NSH is, I would say, more powerful. Not necessarily that is the only solution, but it's the most comfortable solution if you are going to operate the whole infrastructure. As well, because NSH supports something that is additional metadata. You don't have to keep states all over the place. You can move the state along, and this is useful as well. And third, we are thinking about an application that I hope to bring to some of these summits in some moments about precisely something that was we were discussing some time ago with a guy from I don't remember his name, from a bank, in which he was considering that using software-based routing somehow, or software-based chaining was a problem for them because there was no way of assuring that all packets were going through all the functions in the chain, unless you can prove that. And we have been working in something that, I will say it, that uses blockchains. I'm sorry. That's precisely the idea. So what you at the end is computational costly, but at the end, if it is relevant for you, you can have a proof that all individual packets went through the functions in the order you originally required. That normally with physical attachment is something that you can follow, because you follow the yellow cable, the green cable, the orange cable, but now this is not any longer possible.
And on that topic, I think that data plane projects like the FD.io, which allows for easy integration of new headers or data plane functions, will make it easier to adopt NSH-like technologies for sure.
Everyone can get a header.
Yeah. Yeah.
Back to the silo discussion.
Yeah, more silos.
Yeah. Any other comments on SFC? What are folks using? I know I got more users in the audience. Really, we've not thought about this? Which way you're going to go? NSH. Okay, so, all right. Well, cool. Well, then it deserves its somewhat dominant role in what we're doing then. So, fair enough. Again. Another topic that I wanted to bring up was edge computing. Okay, so applications like Central Office reimagined as a data center, CORD, and different types of edge computing. You know, be it what the mobile edge computing definition is inside of Etsy, and then there are other types of applications. You know, this has been done kind of outside of OPNFV. right now in the open source realm. I was looking for an understanding of the group of those types of use cases. How significant? Is this something that OPNFV, along with other controllers and other types of orchestrators, should be working on as concrete use cases as next steps and have a higher priority in what we're doing in the next 12 to 18 months? Or not, basically. So I'm looking for an understanding, a validation of edge computing. Again, I will make these guys say something. That's why they're standing here, in the event that you guys are too quiet. Yeah. But I'd love to hear from the audience. What are your thoughts there around Chord, its value, again, edge computing, its value, and where we should be placing as an open source project, be it OPNFV or OpenDaylight, in the list of things we should look to go attack?
So I'll start talking a little bit about some of the edge. Not necessarily about Chord specifically, but I think one of the ways that we're looking at, especially for maybe a transitional thing or it may stick around, but is really on the customer premise. Right now there's a whole lot of boxes that we're managing from the service provider space for businesses, and really trying to consolidate all those into one box. And so that really is, pushing and managing multiple VMs or VNFs that, maybe containers or something, but out to the edge, and got called in by one of the biggest cable providers recently, and they're like, hey, this is a hard problem, and we don't want to solve it our own way. We want to have one common solution. They don't want to have this whole vendor silo thing. And so how can we kind of work on this? You don't necessarily want to do you want to put a whole OpenStack instance out on your single node at the customer site? I mean, it could work. People have done it, but, or do you want a Nova compute node and all that? So it's really kind of a little confusing on what is the best way to manage it, because you need it to have some level of autonomy, but you also want it to be, very lightweight, very inexpensive, and flexible, and really controlled from a central office, and having more and more of it, be reliable. What happens if it fails during an update and things like that. So there's, I think, a lot of things there where we're going to start managing the operating system like firmware for doing updates with failover, failback. Right. Exactly. They unplug them, and then they're going to want to actually, well, wait, can I just buy my own? And if you allow them to buy their own, then what is the standard for that? Does it need to be ARM, x86, and things like that? So to me, I think it's a really, especially in the cable industry, it's kind of the next big thing, because consolidating all the boxes on the commercial side, it's an easy thing to do. You don't have to go and change as much in the back end to do this. Some other people like Verizon have announced that they're putting everything lightweight in the data center. I think AT&T is somewhere in between. But again, depending on who you talk to, there's different modes. But kind of that's an easy way to start, is you can just push everything to the edge. And by the way, you're not paying for power, you're not paying for, the customer's paying for all that. And so kind of reduces OpEx as well. So again, that, and plus also the analytics, where there's so much data we can look at, and we want to proactively monitor the network, and being able to actually process that and just send interesting things back, as opposed to taking all the upstream network, which is very valuable, for all that information, but you just say interesting events, or hey, everything's been good for an hour, or we've had this variance. So I think edge is huge when you're looking at the wide area network.
Yeah, and I'm definitely biased on that topic, because I've been a big promoter of data utilities. So basically, because of that, we definitely are pushing a lot more computing power at the edge for smart infrastructure management. But also, it has to be virtualizable and have the ability to run everything in containers locally, so that you can have the operational constraints, and as you mentioned, the ability to manage the firmware, try to put whatever you want, however you want. We've been basically leveraging FIDO and some of the proof of concepts that we have here at OPNFV, but really, I think it's really about changing that operational environment. And to get back to Chord, I think Chord is a very nice white box focused or open flow focused use case for some of that problem solving, but there's also other ways to address this based on what you are trying to achieve? Are you trying to simply provide the ability to back all the traffic to your VNFs, or are you actually running gateway applications? Is that also a Z-Wave Zigbee agent or LoRa read? What is it that you're actually gathering, and what are the end devices? Is it an RFID rain type of reader? Based on what is actually connected at the edge, you will have some different strategies into your mobile, your CPE, virtual CPE strategy. Edge.
Okay, very good. Comment?
I think we obviously do a lot of work with IoT and what we think will happen with 5G. And one of the things we see already is the use cases that come up are absolutely nothing like you would think that they would be. And it will come down to how those price points of the edge devices go down, the kind of business opportunities that will be enabled by it. So I think we have a use case here in Germany where we have what we call a connected vineyard, where we're monitoring, the weather conditions, the sunlight, to work out the best day to pick the grapes to make the best possible wine. You would think that would be a completely impractical way of doing it, but that's one case. And as those edge devices come down, that could be applied to all types of agriculture. So I think one of the early learnings that we have is we have no idea how this technology will be used going forward. And given that that's the case, then we need to build a network in a really flexible way. And to be able to then move the compute to where the data is in many cases, because you don't want to move the data around the network, because in some cases it will be huge, and as you said, you actually only want to pick out the very small amount of data there that's actually useful. And in the other case, you'll have the device that sends one notification every 3 years. And how do you make money out of that as an operator, seeing you have to provide connectivity for 3 years before you get your one message? As a use case that we have with another operator that has provided security devices on a mobile prepaid subscription for very little money. So I think the summary for us is that we will need to build a network that allows you to move workloads around to wherever it's most appropriate to process it. It could be any kind of VNF depending on the kind of workloads. And then we need to work towards building that kind of network, which we have no idea of what the actual use case will be. Right. So that provides quite a number of challenges. Do we need to start that work this year? We need to start some of the work this year. I think we're very much focused on building a network for the VNFs that we know that we have and we need to work with. But for sure, we see the need to be able to support these kind of scenarios going forward, because if we don't have those capabilities in the network, then of course the use cases can't come forward, because that capability has to exist before the device gets put into the location to provide the kind of information that it will go going forward.
Yep.
And you brought up a great point, which is traditional economics of networking has been like the cheaper cost per port and really going as cheap as you can to move the data. But as things are changing and you start to want to co-locate compute, it really changes how you approach the problem from a price point perspective. With better processors, embedded processors from Intel and everything, makes the whole problem different.
But it's much more expensive to move the data than to move the...
Exactly.
Mm-hmm. Hi, my name is Tetsuya Nakamura, and I'm now belong to Gaara and work together with Randy. But many of you know, half of you may know, so most of my career is NTT Docomo, and I joined the Gaara in the end of last year. So when I initiated the HNV and the OpenNV with Diego and a couple of other operators, so one of the rationale and the motivation to initiate the HC make mobile edge computing is because to how to reduce the traffic in the backhaul. Because I'm a core network guy, And given that she said, so one of the very key application will be IoT type of things. So how to reduce the backhaul traffic is very, very crucial for operators' perspective. And so we're gonna have so when I belong to NTT Docomo, so we studied such a very carefully took into account so how to split the functionality to edge computing side, more exactly saying the eNodeB side to more base station nearly, because many of the traffic, especially to IoT type of things, is a very, very low quality. They are not necessary to all the packet to be centralized to proxy to a P gateway and S gateway. So that's why we seriously took into account to how split functionality can be split in the edge side as well as in the more core network side. However, so when we consider not only just how to reduce the traffic, but also TCO model. So most important things for operators' perspective will be so how to reduce the cost, capex and opex. So without any such a justification, it's almost impossible to deploy such a new technology. Especially service chaining type of things that are previously relevant with the previous topic. So if we split the couple of virtual EPC and core network functionality into edge side, we must have some integration in the service chaining, because so each functionality can be more atomic things. So, however, so next question will be, how maybe we can manage such a atomic functions integration like FFC service chaining, because many of the use case is not only virtualized. We must also have some physical network function like a PNF, not only just BNF. Then next question will be how to orchestrate such a more heterogeneous combination, not only just a BNF but also PNF. Then so we realize, because a PNF already managed by existing EMS and the corresponding OSS and BSS. If we seriously take into account such a heterogeneous combination between PNF and BNF, it's quite difficult to without any impact in the existing huge OSS and BSS and the EMS system, because all the carrier, not only just NTT Docomo but the Telefonica and all the other such a big operator has a very huge system already. It's quite difficult to change anything forever. So how maybe we can isolate it, such a BNF type of new technology, including orchestrator, to without any impact, negative impact in the existing OSS and BSS. That's why NTT Docomo decided not to dive into a service chaining type of things, but more focus on the virtual EPC, because the virtual EPC is already centralized and good enough to separate in the very early stage. However, at the end, still NTT Docomo and also in the cable industry, still expect to such a new technology, how to realize that. To do so, most important things is not only just focus on the how orchestrator looks like, but also what is the migration path. Because at the end, but beginning, everything in the existing OSS and BSS to manage EMS and corresponding PNL. And then at the end, maybe 2020 or later, so all the telecom network can be replaced to the virtual. But during that time frame, maybe 5 or 10 years, migration in the heterogeneous coexisting environment is very, very crucial to how to manage such a different and combination. So without any such a migration path, it's quite difficult to introduce any such a very complicated system.
Okay, thank you. Thank you very much for that. Folks, give yourself a round of applause, and please also applaud Mathieu and Randy.